Our side inequality theorem says the following. It says that in a triangle, the longest side is opposite of the largest angle, and the shortest side is opposite of the smallest angle. And while you finish copying that, draw myself a triangle here. So what that tells us is that we know the angle measures of a triangle. We may not know what the side lengths are, but we can at least arrange them as far as relative lengths without much else. So for example, in our triangle here, what should the largest side be, the longest side? What should that be, Greg?
AC.
So AC is the largest, and what's the second largest? Should be opposite the second largest angle, which is AB. And then what's the smallest side? BC. The angle inequality theorem is essentially the converse of this. So it's going to look very, very similar. It's not the same. It's the reverse idea. It says that in a triangle, the largest angle is opposite the longest side, and the smallest angle is opposite the shortest side. Again, these things are very extremely similar. The main difference is that in our first one, we know the angles, then we can compare the sides. In the second one, we know the sides, and we can compare the angles. They're very, very similar ideas. They're just, one's just the converse of the other, one just the reverse of it. But they're both true, which is kind of nice. Recall we saw way back when we started looking at conditional statements that a statement's converse is not necessarily true. In this case, it happens to be. It's a biconditional. If you know the angles, we can compare the sides. If we know the sides, then we can compare the angles. So for example, if I said this is like about 35, 30, and 25. We have lovely triangle ABC again. Where does the largest angle have to be? Which angle must be the largest angle? A. Why angle A? Because it's opposite of the largest side. So here's the longest side. There's got to be my largest angle. There's the next largest angle.
C.
B. So the next longest side is 30. Therefore, my next largest angle must be opposite of that, which is angle B. So the shortest, so then our smallest angle is got to be opposite the smallest side. Here's smallest side. There's my smallest angle. Okay. Again, as with before, just because a side is, say, twice as long as another side, that does not say anything about that the angle is twice as big as the other angle. We can't compare, we can't calculate the measures, but we can do a comparison. We just know it's bigger. How much bigger is anyone's guess, but it definitely is bigger, is what these say. So we got a quick little exercise here. Here's two guys. List both the sides and the angles from largest to smallest. In each of those, one of them should be painfully obvious. I basically told you. And the other one, you have to actually use like the comparison ideas that we just had before. So find both for each picture, the largest, the side lengths from largest to smallest, and the angle measures from largest to smallest. Angle Q, angle P, angle R. Sure. In B, how about the angle measures? We'll start out there because those are the ones that are going to build in. Christine?
Angle F,
Angle E, and we calculated angle E to be what? 33. Okay. So for sure, F, D, and E. So then side lengths in order from largest to smallest then, by knowing that. Becky?
DE, EF, and DE. Oh, shoot, I messed up. Sorry.
DE,
I wrote DE twice.
DE, and then which one?
EF, or EF.
EF, and then what?
EF.
Yeah. Sure. Absolutely. Okay. Using just the comparison terms. On the back side, there's one more, but I'd like you to try to solve this without having to calculate the measure of any angles or any extra sides. So you definitely can't calculate the side lengths. But I think you can reason through this without even calculating what this angle is. Okay? See if you can answer these two questions without doing any calculation of what this measure actually is, without calculating it directly. Create a little track, one thing here. Oh, sorry, angles. Okay, what's the smallest and largest angles of the triangle?
Angle D is the smallest.
Angle D is the smallest. How did you know angle D is the smallest?
Because we know that angle F is the largest. Because
Angle F is clearly the largest. Has to
the
be.
angle is large.
Yep.
And then E, we don't know the angle measurement. We know it's less than 100.
Yeah, it's clearly less than 100. It's clearly less than.
And then it's
I
more.
mean, you can calculate it directly, but can we solve this without calculating it directly? Without typing in and without knowing what that measure is, can we solve this problem without calculating it directly? Anna?
Yes, you can, because you see that angle E correlates to DF, and angle F, since it's the greater, then obviously obtuse and greater,
Yep.
the less calculation DE. And since angle D is 18, which would be less than the side length that angle E correlates to, then it must be
So the only two possibilities for smallest are these two. And we know by the comparison theorem before that since 18 is less than 24, angle D must be less than angle E. So angle D must be the smallest angle. And then using the same idea, now that we know the smallest and largest angles, then the shortest and longest sides, the shortest side therefore must be opposite angle D, which is EF. And the longest side must be opposite of angle F, which is ED. Okay, you could solve it by calculating the angle directly, or without doing that, you still have enough information by the angle comparison theorem. All right. This is our last theorem for today, and it's probably the most important one. You may want to put a circle around it, put a star next to it. It's going to be really important for this course. It's important, but it's actually surprisingly, incredibly important as you move on to like upper level mathematics. If you may not use it a ton like next year in Algebra 2, and maybe not much after you leave this class in high school, but for the few in the proud of you that go on to take like college level math, at some point, this triangle inequality theorem becomes a very, very large part of like most things that you'll do. The triangle inequality theorem says the following. It says that the sum of any two sides of a triangle is always greater than the length of the third side. Okay. Says that no matter how you choose it, you can always, if you pick any two sides whatsoever in a triangle and you add their lengths together, it's always bigger than the third side. So we'll use it to answer questions like this. Could this possibly be a triangle?
No.
Why not? Because there is a way to pick two sides and add them together so that they're not bigger than the third side. 6 plus 4 is only 10. 10 is not bigger than 11. Okay, let's maybe think a little more visually about this. So let's pretend that I have like my little yardstick here, and this is a length of, let's say cut it off, so it's a length of 11 units or whatever it is. And I put two sides. One side that's, say, 6, and one side that's 4. What would you like to do to be able to make a triangle out of it? If I just had like two sides that are kind of like just flapping over here, what would you want to do? You want to like lay them down so they make a triangle, right? Well, this is only 6, and this is only 4. If I lay them completely flat, do they even touch? No, because this is 11 across, so there's like a gap in the middle. They can't even touch. So if you angle them up, they certainly aren't going to touch. They're just going to go farther away from each other. So they have to be long enough to actually touch if you want to think of it like laying the sides down and along the side. Now, what if they're exactly equal? Do you get a triangle? You get a line. You get just a flat line. You get a straight line. So they can't be exactly equal and form a triangle. If they're anywhere above, even if they're just a tiny, tiny bit above, like a 100th of a 1,000th of a centimeter, you still get a little bit of gap, and you get a tiny, tiny triangle. But they can't be equal. If they're exactly equal, then they just touch and they're a straight line. And if they're less than that, you can't even make it whatsoever. You can't make a triangle whatsoever. The triangle inequality, that's exactly what the triangle inequality theorem says. Is that the only way to make a triangle is to have side lengths that fit that pattern. Okay. So, what if I give you a problem like this? And I tell you 2 of the 3 side lengths. I give you 2 side lengths, and I want to find what are the possible lengths of the third. And this is how I would think about it. I think, well, I have a third side. We'll call it x. X is one of 2 possibilities, and don't laugh because it's going to sound kind of dumb, but it's got to be one of these 2 things. X is either the longest side, or it's not the longest side. Would you agree with this statement? This missing side is either the longest or it's not the longest. Does that seem to be a true statement? It's got to be one of those 2. There's nothing else. It's either the biggest or it's not the biggest. Okay? Let's look at what the implication of each of those 2. What if it's the longest side? What should our inequality look like then? What's the only really important inequality that we care about then, via this triangle inequality? So the sum of any 2 is always bigger than the third. So if we take the longest side and add to any of the other two, is that going to be bigger than the third side? Yeah, it has to be. That's not interesting. We don't care about that. So what we really want to look at is if we add the two shorter sides, that's got to be bigger than the longest. That's like the only case that's even interesting. So if x is the longest, then we should be able to add the shorter sides together. That's bigger than our longest side. Or if x is the longest, what are the two shorter sides of my triangle? What do the two short sides have to be? If x is the longest. The missing one's the longest. What are the two shorter sides? 8 and 12. So that if I added, in case 1, if I added together the two shorter sides, 8 and 12, that must be bigger than my longest side. If x is the biggest, then this inequality must be true. I add the two shorter, and it's got to be bigger than my longest. Okay. Or, how about it's not the longest side? If x isn't the longest side, then what is the longest side? 12. Can 8 be the longest side? No, it doesn't make sense. 12 is bigger than 8. So the longest side, if it's not the biggest, then this guy's got to be the biggest. Then 12 has got to be the biggest side. So therefore, I should be able to add together my two not longest sides, 8 and x, and this inequality better be true. That if I add together my two shorter sides, it's got to be bigger than the longest side. X is either the longest or it's not the longest. Well, what do these two things imply? So then let's solve each of these inequalities. Let's figure out what this implies. Joel?
X either has to be between 20 and 4. So it can't be bigger. So
We solve each of these inequalities, so you get 20 is bigger than x, or x is less than 20. X has got to be bigger than 4. As a compound inequality from your days of Algebra 1, x is greater than 4 but less than 20 would be 4 is less than x is less than 20. Would be a compound inequality for this. X can float in any range in here whatsoever. It can be 4.0000002. It can be 19.99653. Or any of those values in between, any of these less interesting values in between. But it can't be exactly 20, because then you get a straight line. It can't be exactly 4, then you get a straight line. And if it's anywhere outside of this, then the two sides don't even touch. So it's got to fall in this range somewhere.
So can you walk through one of those on the homework?
Yeah, I mean, we can do the second one here, which is pretty much identical to the one in the homework. So let's think about, it's the same idea. If I give you 2, we have a third side. X is either the longest or it's not the longest. If it's the longest, what's an inequality we could set up? Or if it's the longest, then what are the two shorter sides? 11 and 3. So if I add together 11 and 3, that's got to be bigger than the longest side. What if it's not the longest side? Then what is the longest side? And what does 11 have to be bigger than? My two shorter sides, which are therefore 3 and x. It's got to fit one of these two things. So then therefore, 14 is bigger than x, or x is bigger than 8. So what values does x have to fall between? Because it's either the longest side, which means in our interesting case of the triangle inequality, if it's the biggest, then I need to be able to add the two shorter together, and that's bigger than the third. So either add 11 and 3 and it's bigger than our missing side, or it's not the longest side. So I add the two shorter, 3 in my missing side, and that's got to be bigger than the longest, which is, in this case, 11. So this inequality or this inequality is true. Combining those two things, x is less than 14, but x is bigger than 8. And this compound inequality, and the units would be feet.